In this video, I'll show you a novel way to find eye level for a pizza in perspective, and it's all in my book, Ellen's Guide to Perspective, on Amazon. In my last video, I discussed an ellipse in a trapezoid where the major axis of the ellipse is not the important line, but rather the perspective line in the back here, going through the center of the trapezoid where the diagonals cross. Now, why is that? Well, here we have, in this situation, we're looking down at the observer. So this is the observer's head, and this is his cone of vision. And he's looking at a circle in a square. And remember that this ellipse is actually a perspective view of a circle in a square. So the observer sees this red line as the longest line, and he thinks that's the middle of the circle. And that correlates with the major axis here in the perspective view. But in fact, the real center of the circle is right here where the diagonals cross. And this green line to this observer looks smaller because his cone of vision is going like that. So it's not touching this second line. And that correlates with this perspective line in the trapezoid that's behind the geometric line of the ellipse. Let's use the same approach to understand concentric circles in perspective, like a pizza, where this is the thicker crust in front and the thinner crust in back. So here we have the observer, and this is the observer's head, and this is his cone of vision, and he sees this black line as the largest part of the black circle, which correlates with the major axis of the black ellipse. Then he also sees this blue circle, and his cone of vision is like this, so that he thinks this is the largest part of the blue circle, and that correlates with the major axis of the blue ellipse. But interestingly, neither of them is the center of the circle. The center of the circle is behind it. And in our perspective view, also the center of the circle is behind the major axis of both ellipses. Here is something I came up with, which I think is kind of neat. Here we have a pizza. Where's eye level? Well, first, find the center of the pizza, which we can see is right here, and draw a line through that center. And then we have where it touches the ellipse on both sides. And we know that the trapezoid must be tangent to those purple dots. So there's only one trapezoid for this ellipse using this perspective center. And then all we have to do is follow the lines of the trapezoid, and we can find eye level. So if we know the perspective center of the pizza, we can find eye level. Isn't that neat? An ellipse can be enclosed in an infinite number of trapezoids, but there's only one trapezoid where its diagonals cross at the perspective center of the ellipse. So again, let's think of this as a pizza on the table. And now let's lower our eye level and see what happens. The trapezoid is further splayed out. The ellipse becomes narrower. The center is further back, the yellow dot. And the area in front becomes larger than the area in back, and our eye level is lower. So if we think of this as a pizza and we've lowered our eye level, the thickness of the crust in front is even thicker here than it is in this first situation. In contrast to a trapezoid, a parallelogram touches the ellipse at the midpoint of all its sides, so it doesn't appear to diminish with distance. That is, the front part of this form is as large as the back part. There's only one center used by both the parallelogram and the ellipse, and the axis of the ellipse would be like this, and the minor axis would be like this, so that it almost overlaps the diagonals of the parallelogram. Now, there are two problems. One is that the ellipse isn't horizontal. You can see that it sort of tilts, and you couldn't really show a pizza that way. And then the other problem is there's lack of foreshortening. As I said, the front and back are the same length. So it doesn't show us depth. Here I've put some concentric circles in perspective. So this is the major axis of the small ellipse and the major axis of the larger ellipse. Now, if we exaggerate this placement, we get a convex shape like a frisbee. And I always confuse these terms. Think of concave as caving in. So the opposite is convex, where it's pushing out. Now, if we turn this whole configuration upside down, then we get a concave shape like a bowl, assuming that we're looking at it from a bird's eye view. But if we look at this shape from a worm's eye view, it looks concave. It looks like it's caving in. And if we look at this one from a worm's eye view, like looking at a light fixture, it looks convex. Check out my book, Ellen's Guide to Perspective, on Amazon, and please remember to subscribe.